here we're going to solve the inequality. The absolute value of x minus 1 is greater than 2. Before we do that, I want to review a couple of properties of the number line. Specifically, if we choose any value of c greater than 0, we can not only locate a c on the number line, we can also locate its opposite, which this time we'll call negative c, since if c is positive, the opposite of c is negative. These two numbers separate the number line into three intervals, where x is less than negative c, where x is between positive and negative c, and where x is greater than c. Although there are three intervals, when we consider the absolute value of x, there are only two options. For the values of x between positive and negative c, the absolute value of c is less than c. For the two outside intervals, the absolute value of x is greater than c. So we can actually solve any inequality by substituting our values into the number line above. Here we're going to substitute x minus 1 for x, and we're going to substitute 2 for c. And so we will have the absolute value of x minus 1 is greater than 2 in two different intervals, where x minus 1 is less than negative 2, and where x minus 1 is greater than 2. So, whenever I see the absolute value of a quantity greater than some value which I think of as c, I replace that inequality by removing the absolute values and saying that I know the quantity inside has to either be less than the opposite of c or greater than c itself. So now in this particular example, we just have to add 1 to each side. Negative 2 plus 1 is negative 1. In the other case, when I add 1 to each side, x is greater than 3. And so in these two intervals, the absolute value of x minus 1 is to be greater than 2. So the answer, or the solution set for the inequality, involves the interval from negative infinity to negative 1, as well as the interval from 3 to infinity. So we take the union of those two.